Okay, today's lesson we're going to be looking at fitting the line of best fit to our scatter plot, which is known as the least squares regression line. So if you have a look at the least squares regression line, what it does is it minimizes the sum of all the squares of the residual. So let's have a think about that, what that's doing. So we've got our scatter plot. So we have our points on our scatter plot. Okay, so what the calculator does is it's going to try and balance a line in, and it's going to reduce all these distances between like the actual dot and the line is called a residual. And it's going to try and minimize all of them so that it all balances out. And we also saw that that's how the calculator works out the R value, and which also in turn gives the R squared value. So it does this and we get an equation, or we get a line of best fit, which is called the least squares regression line. So that's going to be this line here, and we often refer it to A plus BX. So if we're going to see we would have already seen in our calculator, we get these A and B values where we find the R value and the R squared value. But if we just have a look at this formula, you can see how it's similar to our y equals mx plus c. So except that this B is obviously the gradient and the A value is the y-intercept. Okay, so we're going to see in our calculator where we find these values. So just to be clear, this one is the y-intercept on our straight line. So if this came out, it would be here. And this is our gradient. Now, we're not going to use y and x either. We really should be using our response variable name. And then it will be A, which we'll find out, and B, which we'll find out, and we'll times the explanatory variable. So we're going to get an equation, and we can use the equation to predict what might be happening. So if I talk about like the example we've been talking about through class, so say we've got the height and the weight, so we've got the scatter plot, whatever, and we get this equation. So we might have weight equals 35 plus 20 times your height or something. I'm a bit exaggerating. So if I said if you have a height of 2 meters, what would your weight be? You'd go weight equals 35 plus 20 times 2, example. So 75, whatever. So you can use it to predict values. Okay, so just to make it clear what a residual is. So the residual is the data value, so minus the predicted value. But what you're actually talking about here is the y value. So say, for example, this residual here, it had a y. Say if I went across here and I said its y value was 4, but the line up here predicted 6. So its residual value would be, it actually had 4 and it was predicted 6. So it actually has a negative 2. So you can see that any dot that falls under the regression line, so any of these dots would have a negative residual, and any of the dots above would have a positive residual. And we'll look at residuals later as well, but just if you have to find an individual one, that's how you do it. So a residual is the vertical distance of each data point from the regression line. Okay, so I'm going to have a look at, use our calculator and show you how we get that regression line equation. Okay, so like with all our linear regression equations, we need to make sure that we get the correct EV and RV before we go on, because you'll get the wrong equation. So I'm going to use the example we used the other day. So we've got the test 1, which was our EV, and then we've got RV for test 2. So you've got your two lists in, and you do the same for where you get the R value. So we go menu, starts, start calc, and then we're going to go down to this one, linear regression equation. And we click enter, and then we're asked to put in our X list, which will be our explanatory variable, and then we put in our Y list, and we click OK. So here is, we've been doing our square, but if you have a look here, here is our A and here is our B. So if I wrote out our basic formula, so for this example, because we're predicting what test 2 would do, we do test 2 equals, now I'm going to do the 2 decimal places. So 2 decimal places. We'll have test 2 equals A, so 1.05 plus B, which is 0.95 times test 1, which is our explanatory variable. Okay, so now I have a formula, a least squares regression line, and I could predict. So I might say, predict the score of someone who gets a 15 in test 1. So if test 1 was 15, predict the test 2 result. It would be test 2 equals 1.05 plus 0.95 times 15, and you get your answer, and so on. Okay, we just need to be aware of our significant figures now too. So they may ask for decimal places, or they could ask for significant figures, and it's common in when we're setting up the equations that A and B, they'll ask for significant figures. So just to practice that, if I said 3 significant figures for these two values, so A and B, let's go have a look. So if I look at A, the first non-zero number is 1, so that's my first significant figure. Then I have 2, and then I have 3. So because I've got 3, I look at the third, the one after the 3, the fourth one there, and it's a 9, so it means I would raise the 4 up. So it would be 1.05. So that's 3 significant figures there. If I look at the B, the first non-zero number is the 9, so 1, 2, 3. Then because this number's a 5, that 6 needs to go up. So B would be 0.947. Okay, so just might have to go back and get your notes handy on the significant figures in doing some of these. Okay, there is a way to get the regression line equation onto your scatter plot on the data and statistic page. So you've selected test 1 and test 2, and you have your scatter plot. Now if you press on this screen menu, and then you'll see analyze, and then press you'll see regression, and obviously we're going to put the lin reg A plus bx is what we'll choose, and then it brings up the equation on this on the scatter plot, and you can see a thing. So here's a little residual there that would have this one, this one, this one, this one will have a negative residual. If the dot is on the line like that one, it will have a 0 residual, because if you think about it, the actual data minus the predicted, it's the same thing, so you'll get 0. And above here we'll have a positive residual. Just the thing I don't like about using this one is often people still write y and x when I really should be writing test 2 equals 1.05 plus 0.95 times test 1. So we really need to use the variable names, otherwise we won't get the marks. Also, you're not going to be very careful with decimal places or significant figures. Okay, so a couple of things we need to go over and remember. There's a few, if we're going to use the linear regression, a plus bx, or even the r value or the r squared value, if we're using these, we're assuming it's linear, so that it's following a straight line path. There's no outliers, because an outlier affects all the data readings, because if we have one down here, it's going to drag that line of best fit down there, so then it wouldn't be accurate. So we can only use the linear when we assume it's linear, there's no outliers, and obviously we need two numeric variables. That's pretty self-explanatory. We wouldn't be able to get a scatter plot if we didn't. Alright, so just remember those things when we're doing a linear regression. Okay, there is another way to get the least squares regression line, so the a plus bx, and that is using these formulas. So if you look here, b equals r times sy over s of x. So the sy stands for the standard deviation of your response list, variable list. So it's the standard deviation of your RV list. And then here, obviously, S of x is standard deviation of your explanatory variable list. And so you can use that, and you also need here the correlation coefficient, so the R value as well. So what they're going to have done is given you these numbers, and you have to calculate the least squares regression line. What throws you is often you don't realize that's what you're doing, because it's all written in words and it doesn't stand out as much as using the symbols, because they'll say, oh, the standard deviation of test 2 was this, and standard deviation of test 1 example, etc. So here, when we have that line above the y, that actually means the mean of the response variable list, and this bx is the mean of the explanatory variable list. So obviously if you had the two lists, you would just do it the way we did before. But down here, you can see that we've given you an example of what it will look like. So we'll calculate that one. So here it says the heights of and weights of 11 people were recorded, and the values as follow. So if you look, sorry, that was supposed to be the mean of x and standard deviation and so on. Okay, and mean of y. So they're saying that height is x and weight is y using the thing. So if I was going to go calculate this least squares regression line using the formula, you have to calculate b first. So if I was calculating b, you would use the r value, so it would be 0.8502 times the s of y, which they said was here, 7.5943, all over standard deviation of x, which is 7.4443, and we'll get a value. So I work out that to be 0.8673 or something. Okay, so then if I go to look at to find the a value, you can see you have to find b, because B's in the A formula. So you have the mean of the Y list, so 65.4545 minus B, which is 0.8673, times the mean of X, which is 173.2727. So if we calculate that, okay, so I get negative 84.8249. So if I wrote out the equation, because weight, we'd say weight, and we will put the units, so they said that weight was in kilograms, so we wrote weight in kilograms equals A, which is negative 84 point, I'm going to do 2 decimal places, 82, plus B, so 2 decimal places would be 87 times your height, and I'm going to put the units of height as well, which was written in centimeters. And here's my equation. So I've got the least squares regression equation from that. All right, so today I would expect you to be doing exercise 4A and 4B. This is very quick and a few little questions, and then concentrating on this part. This least squares regression equation and doing all this is the major part of the course, so let's make sure we get this done.